It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
Hello everyone, good evening to all. A369B. So we'll see all of the things. Drupad Saha, good evening. Vamsi Krishna, good evening. Please share the session. Let us reach the session more. Please share the session. Am I audible, guys? So before starting the lecture, let me confirm that. So am I audible, guys? Good evening, Vikash. Please, anyone confirm that am I audible, guys, or not? Yes, it is audible. Let us start the lecture. So hello everyone, welcome to Unacademy. So welcome to Gate Conqueror. So in this session, we are going to discuss about the switching concepts in power electronics, which is the continuation of the yesterday part. So in yesterday we have seen that. So what is the differences between the ideal and practical switches, need of switching in the power electronics, so as well as the placement of switch we have discussed. But in this session, let us discuss what are all the types of switches we have in the power electronics. Let us discuss here. So now let me introduce myself. So I'm Satish Kumar K.S. Reddy. I got the AR 18 and AR 286. So I had a 10 plus years of teaching experience. So I did my MTech from NIT Tiruchi. So I was ex-BHL employee. The subject I was expertise in power electronics, power systems and network theory. So now, so these are the special class features. What are all the special classes here? So in Unacademy Learner app, you will find the free classes. So there you can watch the special classes. So these are all the features here. So one is interactive live classes. So which means you can interact with the learner and the educator. So here the polls for the learner will be created. So for better understanding, you need to answer that polls. So then never miss a class. So when you will miss the class, you will get the notification. So you never miss the class when you are attending for your favorite faculty. So when they have scheduled, so you will get the notification. So the lecture notes can be downloaded in case of special classes. So when compared to the YouTube, so you can watch anytime and anywhere. So now let us see so what are all the subscriptions available? So here plus subscription is there. So if you observe here, so there is a plus subscription and iconic subscription. In plus subscription, we have live classes, crash courses, weekly tests, doubt solving, and the classes will be held in both English and Hindi. So classes will be held in both English and Hindi. So here in iconic subscription, in addition to all the plus features, so we have the personal coach. So you can allot it with the personal coach. So he will guide you like anything. So here the study booster sessions will be conducted. So personalized test analysis will be there. So study planners are there, preparatory study materials also there. So now this is the mega combat, so which is on 29th August. So enroll for this. Now, so let us see the next one. So this is the fee structure of the plus subscription with the inclusion of the plus 10%. So here this is the fee structure for the 12 months, 18 months and 24 months. So similarly for iconic subscription also, this is the fee structure for 12 months, 18 months and 24 months with the inclusion of 10%. So if you cannot able to bear the total amount, so you can opt for the no cost EMI also. So now if you use the code as KSK10, so you will get the 10% discount. So on plus subscription as well as iconic subscription, so that the amounts will be with the exclusion of 10%. So these are the 12 months, 18 months and 24 months. Similarly for iconic subscription also, we have the 12 months, 18 months and 24 months. If you use the KSK10, so you will get the 10% discount. Now, so let us see the offer alert. So if you opt for the 12 months, so you'll get additional 2 months subscription, additional 3 months for SSC, JEE and State AE exams. If you opt for the 24 months, you will get the additional plus 4 months, plus 6 months for the SSC, JEE and State AE exams. So from this you can save this much of amount. So now let us see the next one. So this is the Accelerate and R1 batch which was started at 18th August. So by the best faculty, the first subjects are control circuit and EMF theory. Similarly for ECE also, the batch has started for control systems and EMF theory. So this is the bugs bounty. If you find any inappropriate content in the video, so you can report to the Unacademy. Thereby you can reward from the Unacademy. So if you want to follow my special classes, once I have scheduled, so you'll get the notification. So if you use the @SatishGate. Now let us go into the topic. So here in the last session, as I said before, so we have seen that. So what are all the type? So we have seen that. So differences between the ideal switch and practical switch, analysis of the practical switch, what is the need of switching in the power electronics, as well as placement of switch. Now let us see classification of switches. These classification of switches is mainly divided into 4 categories. So the 4 categories are, so the first category will be based on control action. So based on control, so the switches are divided into uncontrolled switches. So and the second one is semi-controlled switches. So third one is fully controlled switches. So So we have the 4 categories. In that 4 categories, the first category will be based on the control. So based on the control, so it will be the uncontrolled switches, semi-controlled switches, and fully controlled switches. So what is the meaning of the uncontrolled switches? In case of uncontrolled switches, so we cannot control the turn on and turn off instance. So here we cannot control. So we cannot control turn on and turn off instance. Turn on and turn off instance. Turn off instance. And there is no control signal in case of uncontrolled switches. So in case of uncontrolled switches, so there is no additional control signal, so that we cannot turn on and turn off. We cannot control the turn on and turn off. So we will see the examples later. First we will see what is uncontrollable switch. Now, so the semi-controlled switch is nothing but, here we can control, so we can control either turn on or turn off. So we can control either turn on and turn off. So in case of fully control, so we can control both turn on and turn off. We can control both turn on and turn off. Both turn on and turn off instance. So I think you have clear. So what is uncontrolled? In uncontrolled, we cannot control the turn on and turn off. So in semi-control, we can control either turn on or turn off. So in fully control, we can control both turn on and turn off. Now let us see the next classification. So based on the next classification will be based on current direction. So the switches are classified into two types. They are unidirectional current switches, unidirectional switches, and the second one is bidirectional switches. Second one is the bidirectional switches. So based on the current direction, so for example, if switch is carrying current in one direction, either in this direction, or if the switch carrying in the opposite direction, if the current is in this direction, so it is a unidirectional switch. If the switch is carrying the current in both the directions, if the switch can able to carry the current in both the directions, so it is called as bidirectional. What does it mean? So the switch can, for example, this point is A and this point will be the B. So the current can flow from A to B, so it can carry the current from A to B, and it can carry the current from the B to A also. So B to A also. So it is a bidirectional switches. So we have the unidirectional and bidirectional switch. So now let us see the next classification. So the next classification will be based on voltage blocking, polarity. So based on voltage blocking polarity, so they are divided into voltage blocking polarity. They are divided into two types: unipolar switches, and the second one is the bipolar switches. So what does it mean? So blocking means the switch has to be in the off condition. So what is the meaning of the blocking? So blocking means the switch has to be in the off condition. So when switch is in off condition or blocking condition, so which polarity of voltage it can block, it depends on switch power semiconductor device. For example, if it can block, so only one polarity, either this polarity, or if it can block negative polarity. So we can call it as a unipolar switch. So what is the bipolar switch? If it can block both the positive and negative voltages, so we are called as, if it can block both the positive and negative voltages, we can call it as bipolar switch. So if it can block both positive and negative voltages, we can call it as a bipolar switch. If it can block either positive or negative voltage, we can call it as a unipolar switch. We are clear, right? Let us see the examples afterwards. So the next one is according to the, so based on quadrant operation, based on quadrant operation, so based on which quadrant it will operate, so it is divided into three types. So the first one is single quadrant operation. So the second one is two quadrant operation. So third one is the four quadrant operation. So what does it mean? We'll see. So here the quadrant operation is depends on the voltage blocking capability. Let me take the voltage on x-axis. Current on y-axis. So for example, so if it is single quadrant operation means, so it has to be either it has to block, it will operate in the one quadrant. So that means, for example, let me take one example. So if it is blocking the positive voltage, let me represent with the other color. If it is blocking the positive voltage and if it is carrying the positive current, so the graph will be like this, right? If it is blocking the positive voltage and blocking the positive current, the graph will be like this. So some device will exhibit like this. So we'll see later. So if it is operating, if the device is operating like this, so we can call it as a single quadrant operation. So for example, if the device can able to block, so here also negative voltage also, so the device having the capability of blocking the both positive and negative voltage, so that graph can be represented like this. If the current is in one direction, so what happens? So it will operate in the two quadrants. So that is called as two quadrant operation. So if the device can so block the voltage in both the directions, the current can carry in the both the directions, so it will operate in the four quadrants. So it is called as four quadrant operation. So these are all about basic classification of the switches. We have divided total switches into four categories. So up to here we are clear, right? Hi guys, please respond. Be the session most interactive. So here we have studying the classification of switches. So by four categories we have seen up to here. If you are clear, we'll go forward. So we are clear or not? Up to here we are clear or not? So that four categories you have understood or not? Based on the control, based on the current direction, based on the voltage blocking, and fourth one is the based on the quadrant operation. So do you understand up to here or not? Right. So let us go next. So we will see what are all the power semiconductor devices are there. So in a brief manner, so let us discuss when it comes to the power semiconductor devices topic. But here, let me give you a brief introduction about devices. Now, let me take, so we all know that, let me start with the power diode. Let me give the brief introduction what the power diode can do. So the symbol of power diode here is, so it will be like this. So it has two terminals, anode and cathode. So here any control signal is there. We have only two terminals. There is no additional control signal, so that we cannot control the turn on and turn off. If we cannot control the turn on and turn off, so which category will be based on control? It will be in the uncontrolled category. So it will be in the uncontrolled category. Uncontrolled device. So here there is no control signal because of the lack of control signal. So it will be in the conduction state or off state. So we cannot control the turn on and turn off instance. So here, so it will be the uncontrolled device. The power diode is the uncontrolled device. So the next classification is based on the current direction. So is it unidirectional or bidirectional? That we know. It is unidirectional or bidirectional. So in a diode, the current always flows from the anode to cathode. So the current will not allow from the cathode to anode. So it will be the unidirectional. It is allowing the current in the only one direction from anode to cathode, so it is unidirectional. So it is unidirectional. So it is unidirectional. So diode is a unidirectional uncontrolled device. So the next we will see the based on voltage blocking. Based on voltage blocking. So it can block, so it will block the negative voltage. What is it? We will see here. So let me take, so when the diode will be turned on. Let us discuss when the diode will be turned on. So when anode potential is greater than the cathode potential, when anode potential, let the anode potential is VA, cathode potential is VK. When anode potential is greater than the cathode potential, what happens? So the diode will be on position. The diode will be forward bias. When it is forward bias, so it is in the on condition. Diode is in the forward bias condition. So when the diode is in forward bias condition, so it will be in the turn on state. So when it will be in the off state, so when VAK, so when it will be in the off state, when anode potential is less than cathode potential, this diode will be in the off condition. So that means VA is less than VK. So which means VAK is less than 0. So what does it mean? So when we apply the negative voltage across anode and cathode, what happens? So when you apply the negative on cathode, that is VAK is less than 0. So what happens? So when VAK is less than 0, the diode will be in the off state. So here it is blocking the only negative voltage. It is blocking the negative voltage. So during off state, it is blocking the negative voltage. So negative voltage we can represent like this. It is blocking the negative voltage. It is blocking the negative voltage. So that it is not blocking the positive voltage, it is only blocking the negative voltage. So that we can take this as a based on voltage blocking, it will be the unipolar device. It will be the unipolar device. Now we have classified these three. Last one is the based on the quadrant operation. How we can draw the quadrant operation? So if you know these three, that is sufficient. How we can draw? So let me draw the quadrant operation here. Let me draw the quadrant operation also. So here, if I take the voltage on x-axis, current on y-axis. So here, which quadrant it will operate? So let me represent with the other color. Which quadrant will you operate? So it will operate in the, it will block the negative voltage. So that I need to represent here negative x-axis. So the current will be from anode to cathode, it will be the positive. So let me take the anode to cathode current will be positive. So it is operating in the single quadrant. That is second quadrant. So based on the quadrant operation, so it will be the single quadrant switch. So it will be the single quadrant switch. So based on the SOA, here SOA is nothing but safe operating area. So the safe operating area is the second quadrant. So we are clear, right? So now we are clear with the diode. So if you are clear with the diode, if you understand this process, we will repeat for the remaining devices also. So first what we have taken? So we have taken the diode symbol of the device, what are all the terminals we have? So anode and cathode, when it will be turned on and when it will be turned off. So the next we will take the, whether it is uncontrolled or fully controlled or semi-controlled. So whether it will be the unidirectional or bidirectional. So whether it will be the unipolar or bipolar. So whether it will be the single quadrant, two quadrant or four quadrant. So it is operating in which area, in which quadrant we have the safe operating area, we will see here. So the safe operating area will be here, right? So which is second quadrant. SOA is nothing but safe operating area. So we have completed the diode. So let us go for the next device. This much information is sufficient. At this stage. When we study the power semiconductor device, let us go deep into the PN junction. So now at this stage it is sufficient. So now let us see the next device. So next device will be the SCR, silicon controlled rectifier. Let me take the next device as SCR, silicon controlled rectifier. So what is the symbol of silicon controlled rectifier? So the silicon controlled rectifier symbol will be like this. So silicon controlled rectifier symbol will be like this. So it has the anode terminal, cathode terminal, and gate terminal. It has three terminals, anode, cathode and gate terminals. So SCR or silicon control rectifier, which is related to the thyristor family, and it has the 3 terminals. They are anode, cathode and gate. Now, so if you observe the first one, the based on the control, let us discuss for the based on control. So when the SCR will be turned on, when the SCR will be turned on, so it has the control signal, right? So now when the SCR will be turned on, to turn on the SCR, what are all the conditions should be satisfied? So if anybody knows, you can answer. If anybody knows, you can answer. If anybody knows, you can answer. So SOA means safe operating area. Drupal Saha, safe operating area. In that safe operating area only, we need to operate that device. Otherwise, the device will get damaged. Device will get damaged. So let us see the SCR. When will be the SCR in the on condition? So when will be the SCR in the on condition? So here SCR is in the on condition. SCR will be in the on condition when anode potential is greater than the cathode potential. When anode potential is greater than cathode potential, the SCR is in the forward bias condition. The SCR is in the forward bias condition. So unlike diode, here we have additional terminal like control signal, gate signal. So we need to give the control signal. So in addition to this, we need to supply the gate signal. So we need to supply the gate signal. So we need to give the gate pulse so that it will be in the on state. So whenever the gate signal I was given to the SCR, at that instant the SCR will be on condition. If these two conditions are satisfied, the SCR will be in the on condition. So now, so on is controllable. Here on is controllable. Right? So we are clear with this. On is controllable because whenever we are giving the gate pulse, it is getting on. So it is getting on so that it will be the control. Turn on instant is controllable. Let us see the turn off. So what happens during the turn off? So during the turn off, so here to turn off the SCR, if you remove the gate signal, so even if you remove the gate signal, the device will not turn off. So in SCR we need to remember that. So to turn on the SCR, the gate signal is required. But to turn off the SCR, even though we have removed the gate signal, what happens? The device still in the conduction state. So when it will be in the off condition, so the device current has to be 0. So in ideal case, the device current, anode current should be equal to 0. So SCR will be turned off. In ideal case, it should be 0. So in practical case, we will discuss later, but here, so in practical case, it should be less than holding current. IH is holding current, IA is anode current. When anode current is less than holding current, the device will be turned off. In practical case, it will be like this. So in ideal case, it will be anode current should be 0. Now let us discuss for ideal case itself. So here, these are all the two conditions. So here, off condition is not uncontrollable. Off is uncontrollable. So now, SCR is the semi-controlled device. Why? Because the turn on instant can be controllable, but turn off instant cannot be controllable. So the turn on can be triggered by the gate signal. The turn off can be, we can make turn off by making the anode current is 0 or anode current reduced below the holding current. So if this condition is satisfied only, the device will be in the off state. So it will be the semi-controlled device. It comes under the semi-control. So it is the semi-controlled device. It will be the semi-controlled device. So here, up to here we are clear. So the next one, based on the current direction. So is SCR is unidirectional device or bidirectional device? So is SCR is unidirectional device or bidirectional device? SCR is unidirectional device. Why? Because the current flowing to the SCR is always from the anode to cathode. The current is flowing from the, always it allows the current from the anode to cathode. So that it is unidirectional device. It is unidirectional device. Unidirectional device. So based on the voltage blocking. So here it can block both positive and negative voltage. So it can block negative voltage, that is obvious, but it can block the positive voltage also. So unless we are giving the gate signal, even if you apply the positive voltage, it won't get turned on. That means it is blocking the forward voltage also. Let me give the clear idea. Let me give the clear idea about this one. So based on voltage blocking, So based on voltage blocking, so it is bipolar. It is bipolar. It can block both positive and negative. Both positive and negative. Let us see. Let us see. So here, so we have the x-axis on voltage blocking. On x-axis, let me take the voltage blocking. So on y-axis, let me take the current flowing through the switch. Current flowing through the switch. So here, the current is unidirectional, that is fixed. Current is unidirectional, that is anode to cathode. So the current is unidirectional. So the current will be positive. It will always be positive. So, but it can block both positive and negative. It can block both positive and negative voltage. So both positive and negative voltage. So why? Because, so it can block the negative voltage, that is obvious, but it can block the positive voltage also. Why? So here, so as I said before, to turn on the SCR, two conditions are required. What is the first condition? So the SCR should be forward bias. Even though SCR is forward bias, that is not sufficient. So even though it is forward bias, it is still in the off condition until the gate signal is applied. Until the gate signal is applied. So that, so it blocks the both positive and negative voltage. Both positive and negative voltage. So it will operate in the two quadrants. So two quadrants. It will operate in the two quadrants, so that it will be the two quadrant switch. It will be the two quadrant switch. Two quadrant switch. So what is the safe operating area here? So the safe operating area in between the 1 and 2 quadrants. The safe operating area is the 1 and 2 quadrants. The safe operating area of the switch will be the 1 and 2 quadrant. 1 and 2 quadrants. So up to here we are clear. So we are clear for the SCR. So we are clear for the SCR, and so we are clear for the diode. If you are clear, let me go forward. If you are clear, let me go forward. Share the session, guys. Share the session, guys. If you are clear, let me go forward. If you are clear, let me go forward. So now let me take the other device. Let me take the other device. So let me take the other device, which is GTO, gate turn off thyristor. GTO means gate turn off thyristor. Gate turn off thyristor. So now let us see the GTO. So here the GTO symbol will be like this. GTO symbol will be like this. It is also having the anode terminal, cathode terminal, and gate terminal. Cathode terminal and gate terminal. So it has the three terminals: anode terminal, cathode terminal, and gate terminal. So when it will be turned on? When it will be turned on? So it will be turned on when VAK, so that is voltage across anode and cathode, is greater than 0. So that is forward bias. So during that condition, if I supply the gate pulse, positive gate pulse, if I supply the positive gate pulse, the device will be in the on condition. The device will be in the on condition. So it has the control terminal. So this similar to the SCR. So it has to be anode and cathode. It has anode and cathode. When anode cathode voltage across anode cathode voltage is so greater than 0. So after that, if I apply the positive gate pulse, what happens? The GTO is in the on condition. So it was controllable. On state is controllable. On state is controllable. So for off the GTO, to turn off the GTO, we need to supply the negative pulse. If I give the negative pulse, so negative gate pulse, if I give the negative gate pulse, the device will be turned off. The device will be turned off, which means turn off also controllable. So it is controlled by the control signal. Controllable. So GTO, we can take the GTO as, so based on control, so it will be the fully controlled device. We can take the GTO in the fully controlled device. Fully controlled device. GTO is the fully controlled device. So here, so now based on the current direction, it is similar to the SCR. It allows the current from the anode to cathode. So based on current direction, it will be the unidirectional current. Unidirectional switch. So based on voltage blocking, similar to the SCR. So it is also blocks. Let me take the voltage on x-axis, current on y-axis. Voltage on x-axis, current on y-axis. So it is also blocks. So both positive and negative. So it can block both positive and negative. So it allows the current in only one direction, that is positive direction. So it is a bipolar unidirectional device. So the voltage blocking will be bipolar. So based on the quadrant operation, so it is also 2 quadrant operation. The number of quadrants it is operating is 2. So based on the quadrant operation, so it is the 2 quadrant operation. So in which quadrants we have the safe operating area? 1 and 2. So 1 and 2. So we have the safe operating areas for 1 and 2. So it is about ZTO. So now let us see the next device, TRIAC. Let us see the next device, TRIAC. So for the TRIAC, so the symbol of TRIAC is, so let me draw the symbol of TRIAC. So the symbol of TRIAC will be like this. So it has the 3 terminals, MT1, MT2 and gate terminal. So MT1 and MT2 and gate terminal. So when MT1 is positive, so to turn on the TRIAC, so here the TRIAC is similar to the SCR, so anti-parallel connection of SCR. So TRIAC can be defined as if the 2 SCRs are anti-parallel, if the 2 SCRs are connected in anti-parallel, so we can call it as a TRIAC. So because of the 2 SCRs are connected in anti-parallel, so here the current direction is bidirectional. So because the next one is, so here to turn on the TRIAC, the MT1 terminal should be positive. And MT2 terminal should be negative. So MT2 terminal should be negative. So during that condition, if I supply the negative pulse, so negative gate pulse with respect to MT1, so it will be on. This condition should be satisfied. So one more condition also it should satisfy. So 2 conditions are there. For example, if MT1 is negative, so MT1 terminal polarity is negative. So MT2 terminal polarity is positive. So if I supply the positive pulse, with respect to MT1, so again it will get turn on. So the turn on can be controlled by the gate pulse. Here the turn on can be controlled by the gate pulse and the current can flow in the both direction. But turn off is uncontrollable. So in TRIAC, the turn off is uncontrollable. Turn off is uncontrollable. So here the turn on is controllable and turn off is uncontrollable. If the turn on is controllable and turn off is uncontrollable, so we can call it as a semi-controlled switch. Semi-controlled switch. So now based on voltage blocking, so it can block both positive and negative. It can block like SCR, it can block both positive and negative. So it will be the bipolar blocking. So now let us see the quadrant operation. In how many quadrants it can operate? So let us see. So let me draw the voltage axis here. So let me draw the current axis. So voltage and current axis. Let me draw the voltage and current axis. So here, so it can allow the bidirectional current. What does it mean? It can allow the current from MT1 to MT2, as well as it can allow the current from MT2 to MT1. That is bidirectional. So we have the both positive and negative currents. So here the current will be like this, both positive and negative. So here it can block the, like SCR, it can block the both positive and negative voltages also. So if you observe the safe operating area is exist in all the 4 quadrants. The safe operating area will be exist in all the 4 quadrants. 1, 2, 3, 4 quadrants. So that the TRIAC is called as 4 quadrant switch. 4 quadrant switch. Based on safe operating area, so which quadrants it is operating? So all the quadrants 1, 2, 3, 4. So in all quadrants it has the safe operating area. So this is about TRIAC. So let us see three more devices. They are BJT, transistor, MOSFET and IGBT. So now let me take the BJT. So BJT is nothing but bipolar junction transistor. Let me take the BJT, bipolar junction transistor. So what is the transistor symbol that we know already? So the transistor symbol will be like this. It has three terminals. Base, collector and emitter. Base, collector and emitter. So it has three terminals. So the transistor has three terminals, base, collector and emitter. That is clear. So now we will see that, so based on control, whether it is fully controlled or semi-controlled. Let us see. So to turn on the BJT, as a switch, what I have to do? So the collector to emitter voltage should be greater than 0. That means VCE should be greater than 0. So that it will get forward bias. So VCE should be greater than 0. After that, we need to supply the base pulse, the pulse to the base terminal. We need to supply the pulse to the base terminal, control signal to the base terminal. So when you supply the base current, the device will be in the, so control signal to base terminal. So if these two conditions are satisfied, so what happens? The BJT will be in the turn on state. Now the device is in the turn on state, so it is controlled by the control signal. To turn off the BJT, what we have to do? So we need to make the base current as 0. If I remove the base pulse, or if you remove the base current, so what happens? So even though it is in forward bias condition, so what happens? The device will be in the turn off state. So if I remove the base signal, base control signal, so what happens? The device will be off state. The device will be in the off state. So these are all the turn on and turn off for the BJT. Here, if you observe here, what we have to observe? So to find the based on control, whether is it fully controlled or semi-controlled? So is it fully controlled or semi-controlled or uncontrolled device? So is BJT is fully controlled device, semi-controlled device or uncontrolled device? Is BJT is fully controlled device, semi-controlled device or uncontrolled device? So observe guys. So BJT is fully controlled device. Why? Because the turn on is controlled. The turn on is controlled by the control signal. The turn on, when I give the control signal, what happens? This switch is getting to close. So when I remove the control signal, what happens? This getting turned off. So I can control the both turn on and turn off instance so it will be the fully controlled device. It is a fully controlled device. It is fully controlled device. So based on current direction in a BJT, the current is always flows from the collector to emitter. The current always flows from the here collector to emitter. So here unidirectional switch. It is a unidirectional switch. The BJT can also called as unidirectional switch. Unidirectional fully controlled switch. So and it will be the based on voltage blocking, it can block the positive voltage. How I am saying that it can block the positive voltage? Even though I am giving the positive voltage, is that sufficient to turn on the BJT? No. So I need to give the additional base signal during that time only, so the device will be in the turn on state. So if you observe here, so the positive voltage is not sufficient to turn on the BJT. In addition to that, we need the base signal so that it can block the positive voltage. So the voltage blocking will be, again let me draw the voltage and current. So what is the voltage blocking? So let me draw. So voltage, it can block the positive voltage. Positive voltage means in which direction we need to draw. So in positive X direction we need to draw. So it can block the positive voltage. So it can allow the unidirectional current. So unidirectional current is nothing but, so it will be like this. So it is operating in the first quadrant. So it is a single quadrant switch, right? So it can block the only positive voltage. So that is unipolar device. So here, so based on quadrant operation, it is a single quadrant switch. It is a single quadrant switch. Single quadrant switch. Single quadrant switch. Based on safe operating area, so in which quadrant it will be safe. So if you operate the BJT in the first quadrant, so it will be the safe operating area. So we should operate the safe operating area in the first quadrant. So it will be the first quadrant. So first quadrant. So the BJT is, the final conclusion is, BJT is fully controlled, unidirectional, unipolar, single quadrant switch. Single quadrant switch. So now let us see the next device. Now let us see the next device. So let me take the MOSFET here. So a MOSFET has three terminals. Let me draw the MOSFET. A MOSFET has three terminals: drain, source and gate. So the MOSFET will not exist without parallel diode. So the parallel diode will be inherent property of the MOSFET. So if anyone mentioned that, so it is a MOSFET, so the MOSFET itself, it has the internal body diode that we will discuss when we study the MOSFET. So here, so it has the internal diode that we represent like this. So MOSFET has the drain, source and gate terminals. So MOSFET has drain, source and gate terminals. So D stands for drain, S stands for source, G stands for gate. It has three terminals. It is a three-terminal device. So based on the control, let us see whether it is a fully controlled device or semi-controlled device. So let us see. So if you observe here, so this MOSFET, so will be turned on. This MOSFET will be turned on. So when it will get turned on, when drain source is positive, will be positive. When VDS is greater than 0, that is drain to source voltage is greater than 0. So one more condition it has to satisfy. So we need to supply the gate signal across the gate and source. So in between the gate and source, we need to give the gate signal here. We need to supply the gate signal. If I give the gate signal when VDS is greater than 0, so what happens? So if I give the gate signal, so what happens? The device will be in the turn on state. So that it is controlling by the control signal. So that is turn on is controllable. Now we got turn on is controllable. So here the turn on is controllable. How the device can be turned off? So the MOSFET can be turned off by removing the gate signal. If I remove the gate signal, if I take the ideal MOSFET, it will immediately turn off. So if I remove the gate signal, what happens? The MOSFET will be turned off. So turn off. So the turn on and turn off both are controllable. The turn on and turn off are both are controllable by the control signal. So this device can be called as, based on control, which device it will be the? So answer guys. So let the session be the more interactive. So here, so if you observe here, so whether it is fully controlled or semi-controlled device. So it is a fully controlled device. So because it is controlled by the gate signal. It is a fully controlled device. So when we discuss the characteristics and complete construction of MOSFET, we will discuss everything. So like switching characteristics, so voltage and current characteristics, VI characteristics and all we will discuss when we discuss the power semiconductor devices in the MOSFET. When we discuss the MOSFET in the power semiconductor device. But here, let me give the brief idea about MOSFET. So the MOSFET can be turned on when drain to source voltage is greater than 0 and the gate signal is applied to the MOSFET. So what happens? It will be turned on. So when it will get turned off, so when gate signal is removed from the MOSFET, the MOSFET get turned off. The MOSFET will be turned off. So here the MOSFET will be turned off when I remove the gate signal. So here, so the turn on and turn off both can be controlled by the gate signal, so that it will be the fully controlled. So whether it is based on current direction, so whether it is unidirectional or bidirectional. Let us see. So let us see that condition. So based on current direction, if you observe, the MOSFET can allow the current from the drain to source. The MOSFET can allow the current in the drain to source. If MOSFET is on, so in this switch, if MOSFET with the exclusion of diode, so when it is on condition, what happens? So the current is always flows from the drain to source, D to S, drain to source. The current always flows from the drain to source. But in case if the diode is in on condition, if the diode is in on condition, what happens? If the diode is in on condition, the diode current is always flows from the anode to cathode terminal, so that the current flows from the source to drain. The current flows from the source to drain. So the current flows from the source to the drain. Source to drain. So from this we can conclude that, so based on current direction, so it will be the bidirectional. So based on voltage blocking, so it will be the, so what it will be the, so it can block the positive voltage. So observe here. So let me take the reference polarity will be here, plus minus. Let it be the reference polarity. So if it is like this, let me take it as a positive. So if the drain and source, when drain is connected to the positive, source is connected to the negative. So what happens? The MOSFET is in the forward bias condition. So the MOSFET is forward bias condition is sufficient to turn on the MOSFET? No. So we need to supply the gate pulse. That means, so before the gate pulse is applying, so even though we are applying the drain to source voltage, so what happens? The MOSFET still in the off condition. That means it blocking the positive voltage. It is blocking the positive voltage. So voltage is, it is blocking the positive voltage. Now let me confirm that. So it is blocking the positive voltage. So now, so let us observe. For example, if I take this diode, so is it blocking the positive voltage or negative voltage? When it is off condition, when it will be in the off condition, when anode is negative, and this will be the positive. This polarity and this polarity both are same. This polarity and this polarity will be same. So if the reference polarity is positive, so this polarity we can make it as a, we can think that as a positive. So that this diode is also blocking the positive voltage because it is connected in the reverse direction. Don't confuse here. This diode is blocking the positive voltage. So here MOSFET is also blocking the positive voltage. Why? Because this diode is connected in the reverse direction. So that it is also blocking the positive voltage. The MOSFET with anti-parallel diode blocking the positive voltage. So here it is blocking the positive voltage, so that it will be the unipolar switch. It will be the unipolar switch. Now let us see. So it will be the bidirectional current. So the current will be bidirectional, both positive and negative. The current will be bidirectional. So voltage is unipolar and the current is bidirectional. So this can called as which quadrant operation? So this can called as a two-quadrant operation, because the switch is operating in the two quadrants. So here the first quadrant and fourth quadrant. So it is operating in the both first quadrant and fourth quadrant, so that it is operating in the two-quadrant operation. It is a two-quadrant operation. So the next one is the safe operating area will be the first quadrant and fourth quadrant. So first quadrant and fourth quadrant are the safe operating area. Now let us see the last device, so which is IGBT. So now let us see the last device here. So here, let me take the IGBT here. So IGBT has three terminals. IGBT is nothing but insulated gate bipolar transistor. IGBT is, so this device is IGBT. So which is nothing but insulated gate bipolar transistor. So which has three terminals, collector, emitter and gate. So which is having the three terminals, collector, emitter and gate. So when will be the IGBT in the on condition? When IGBT is in the on condition. So the IGBT is in on condition when VCE is greater than 0. So it has to satisfy two conditions. The first condition is VCE should be greater than 0. So it should be followed by VCE should be greater than 0. So and then we need to apply the gate pulse. So we need to apply the gate pulse. We need to apply the gate signal across gate and emitter. So if these two conditions are satisfied, the device will get into the on state. So when it will be the off state, if I remove the gate signal, the IGBT will be the off state. So if I remove the gate signal, if I make gate current as 0, so gate voltage as 0, so what happens? So it is voltage control device. If I make the gate voltage as 0, so what happens? So it will be turned off. It will be turned off. It will be turned off. So here on state and off state both are controllable by the control signal. Both are controlled by the control signal. If I add the gate pulse, if I supply the gate pulse, the device into the on state. If I remove the gate pulse, the device getting into the off state. So it is a fully controlled device. 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 So the next one is, so here whether it is a bidirectional and unidirectional. Bidirectional or unidirectional. So observe here, the current is only flowing from the collector to emitter. The current is only flowing from the collector to emitter. If the current is flowing from the collector to emitter, so it will be the unidirectional. It will be the unidirectional. It will be the unidirectional. Unidirectional. So it will be unidirectional. So the next one is voltage blocking. It is blocking the positive voltage, right? It is blocking the positive voltage. So what does it mean? When VCA is greater than 0, that is positive voltage. So it is blocking the positive. Even if you apply the positive voltage, unless we are giving the gate signal, the IGBT is still in the off state, so that it blocking the positive voltage. So it is blocking the positive voltage. If I taking the voltage and current here, so it is blocking the positive voltage. It is blocking the positive voltage. So the current is also unidirectional. The current is also unidirectional. So it is operating in the first quadrant. It is operating in the first quadrant. So that it is a single quadrant operation. So it is a unipolar switch, and it is a single quadrant operation. Single quadrant operation. So in which quadrant it is operating? The safe operating area is the first quadrant. The safe operating area is the first quadrant. The safe operating area is the first quadrant. So the IGBT can termed as fully controlled, unidirectional, unipolar, single quadrant switch. Now let me take a parallel diode for the IGBT. Let me take the parallel diode for the IGBT. What happens we will see. Let me take the parallel diode for the IGBT. Now if I take the parallel diode, for the IGBT, so what happens? So these condition, it is fully controlled, right? It is fully controlled because if I supply the gate signal only, it will be in the on condition. If I remove the gate signal, is off condition. So this will not change. It is fully controlled. It is fully controlled. So the next condition is, so it is unidirectional or bidirectional. So it is bidirectional because, so the IGBT will allow the current from the collector to emitter. The IGBT will allow the current from the collector to emitter. So here, this diode will, when the diode is in on condition, what happens? The current will flow from the emitter to collector. When diode is on, the current is flowing from the emitter to collector. So when IGBT is on, the current is flowing from the collector to emitter. So that the current is bidirectional. The current is bidirectional. So if it is IGBT by diode, so in this case, for this circuit, so the current is bidirectional. The current is bidirectional. So this can be called as composite switch, which is the combination of two switches. So IGBT and diode. So we can call it as a composite switch. This switch we can call it as a composite switch. So that is anti-parallelly connected the diode with the IGBT. We have connected the diode with IGBT. So now, so it is blocking the positive voltage or negative voltage. So it is blocking only positive voltage. So we have discussed in the MOSFET. So the IGBT will block the positive voltage. If I take the reference polarity of the positive voltage like this diode is also blocking in the same manner because the diode is connected in the reverse direction, so that it is also blocking in the same direction. So it is a unipolar device. So let me take it other color. So it will be the unipolar device. So this composite switch is the unipolar device. Now let us take the single quadrant operation. Here it will be the single quadrant operation before. Now let us see. So in which it is the quadrant operation. So let us see the quadrant operation of this composite switch. So how? So here the current is flowing in both the directions. If you observe, the current is flowing from the collector to emitter as well as emitter to collector. So that current will be in the both the directions. How the voltage will be? So it is blocking the only positive voltage. So if you observe that, what we have to observe here. So it is the 2 quadrant operation. It is a 2 quadrant operation, and it is operating in the first quadrant as well as fourth quadrant. So it is the 2 quadrant operation, and it is operating in the first quadrant and fourth quadrant. It is operating in the first quadrant and fourth quadrant. So this is the difference between the IGBT and IGBT with the anti-parallel diode. So now we have completed up to basic device introduction. So let us see the quadrant operation. So because the most of the questions are asking from the quadrant operation. Let us see the single quadrant operation, 2 quadrant operation, and 4 quadrant operation. So here. So now let me see the single quadrant operation. So up to here we are clear, right? So if any doubt you can ask, guys. So why BJT is unipolar? The BJT will always operate in the, so when BJT will always operate in the by the positive voltage. So here, so it is a unipolar device because, so the BJT, so the question is why the BJT is unipolar device? So the BJT will always operate in the positive voltage, with the positive voltage. That is, if you see the characteristics of the BJT, VCE versus IC. So what happens? So it will be like this. The characteristics will be like this. So here, so for the different base current, the characteristics will be like this. Because here we are using the transistor here, so we are using it as a switch. So it will operate in either cutoff region or saturation region. So it will not operate in the active mode. So and here we need to give the positive voltage. So because we are calling it as a unipolar, so because it is blocking the positive voltage, how it will be, we'll see. So for example, I applied the VCE to the transistor. Is that sufficient? To turn on the BJT? I applied the VCE. Let me take the VCE here. IC. So VCE and IC. So here, if I apply only the VCE, so it will not turn on. So after some base current, if I apply the base current, for the base current 0, the device will not get turned on. So if I slowly increase the base current, what happens? The device starts conducting. So up to here it will not conduct. So after that only the device will be in the conduction state. The device will be in the conduction state. When I supply the base current only, the device will go into the conduction state. So that it is blocking up to this voltage, right? This positive voltage it is blocking. Until I am giving the base signal, the device will be in the off state. That means it is blocking the positive voltage. So here, let us see the single quadrant switch. Single quadrant switch clearly. So what is the meaning of single quadrant switch? What are all the possibilities of the single quadrant switch? So let us see here. So here, let me take, so what are all the possibilities of the single quadrant? For example, if it is operating in the first quadrant, so it will be like this, right? So this switch will be operating in the first quadrant. So the next will be, what is the next possibility? So it can operate in the second quadrant. So the second quadrant will be like this. It can operate in the second quadrant. So here the voltage and current will be like this. So the next possibility will be third quadrant. So in third quadrant it will be operate. The next possibility will be third quadrant. The third quadrant here it will be like this. So in third quadrant, so the possibility will be, so the voltage is negative, current is also negative. So what is the next possibility of the single quadrant? The single quadrant operation on next possibility will be, so the fourth quadrant. So the single quadrant switch is nothing but, if you observe all this circuit, what you can observe here. So in the first graph, what we have to observe, so it is blocking the positive voltage. It is a unidirectional positive current. So if you observe the second graph, what you have to observe here, so it is having the unidirectional positive current and it is blocking the negative voltage. In third graph, what we have to observe, so here, so the voltage blocking is negative, current is also negative, both are negative. So in fourth quadrant, so the voltage blocking is positive, and the current is also positive. So if you observe all these cases, so we can term it like, we can term with the same term. So what is that term? So which is a unidirectional and unipolar. Unidirectional and unipolar. So the single quadrant switch is also called as unidirectional unipolar, because so in all the cases the current is in one direction. So in all the cases the voltage blocking is also one direction. So voltage blocking also, so one polarity. So which polarity? So here it will be the positive, here it will negative, and here it will be the positive. So from this, so the single quadrant switch is also called as unidirectional unipolar switch. If you know that, so what are all the examples for the single quadrant switch? So the diode is single quadrant switch. So it is blocking. So in which category it will falls? So the diode is a single quadrant switch. In which category it will fall? It is a unidirectional unipolar switch. So in all three categories, let it be the 1, 2, 3 and 4. Here the 4 category of graphs are there for single quadrant switch. So the diode falls in which category? So let us see. So in which category the diode falls? So here the 4 possibilities are there. For the single quadrant switch, 4 possibilities are there. So in these 4 possibilities, the diode falls under which category? So the diode is unidirectional and unipolar. So the diode falls in which category? So the diode has the positive current. So observe, guys. So Drupad Saha, wrong. One is wrong, because the diode can block the negative voltage. When it will be in the off condition, when negative voltage is applied to the diode will be in the off condition. So that it has to block the negative voltage. So the negative voltage will be here. The current is positive. The current always allows from the anode to cathode. So here the second graph falls for the diode. Now let us see the transistor. Next device, let me take the next device for the transistor. So be interactive, guys. So transistor falls under which category? So here 4 categories are there, 4 different graphs are there. The transistor falls under which category? So the transistor falls under which category? So if you observe here, the transistor can block the positive voltage, it can allow the positive voltage. So in which category it will be? So here the 4 categories are there. In which category it will be? So the transistor can block the positive voltage. So the transistor can allow the positive voltage. Both are positive, means it should operate in the first quadrant, so that it will be 1. So it will be 1. So similarly, let me take the IGBT. So IGBT also single quadrant switch, right? So IGBT falls under which category? So be interactive, guys. If you have any doubt, you can ask now. So be interactive. Guys. So the IGBT falls under which category? So IGBT blocks positive voltage. IGBT allows positive voltage, so that it is also falls under first category. So if you observe that, if you know the single quadrant switch, if you know the basics, if you know the single quadrant switch, so these are all the 4 possibilities. So we can make that. So from these 4 possibilities, we can make that a generalized statement. So which is unidirectional and unipolar switch. So from this unidirectional and unipolar switch, so what happens? So unidirectional unipolar switch. So we can take these 3 devices are the unipolar and unidirectional switch. So we can match these graphs to the devices. So now let us see the next one. So 2 quadrant switch. So let us see the 2 quadrant switch. What are all the 2 quadrant switch? So here the 2 quadrant switch is nothing but, so it should have the, so 2 possibilities are there. It has the 2 possibilities are there. One is bidirectional bidirectional. So one is bidirectional and unipolar device. Bidirectional unipolar device. Bidirectional unipolar device. So the two quadrants which is nothing but so one is bidirectional unipolar device. So what are all the bidirectional unipolar devices, guys? So what are all the bidirectional unipolar devices? So what are all the bidirectional and unipolar devices? So bidirectional and unipolar devices are, if you observe, so the bidirectional and unipolar is nothing but the current should be bidirectional. So it should allow the current in both the directions. So let me give the clear idea. So two quadrants which is nothing but, so the first classification is there are two classifications. The first classification will be bidirectional and unipolar device. The current will be both the directions. The current is in both the directions. The current will be both positive and negative, and it should have the, either it should block the negative voltage or positive voltage. So let me take the positive voltage here. So the bidirectional unipolar device can be identified by by simply observing also we can identify whether it is bidirectional or whether it is a two quadrant switch or a bidirectional unipolar switch, we can directly observe. So how it is, let us see. So the anti-parallel connection. So the anti-parallel connection switches are bidirectional switches. Anti-parallel connection switches are bidirectional switches. So anti-parallel connection switches are the bidirectional switches. So what is the meaning of the anti-parallel connection switches? So this two quadrant switch and four quadrant switch, so we will discuss later. So tomorrow I will solve the numerical problems about switches. So this two quadrant and four quadrant we will discuss later. So because battery is going to die. So here, thank you for attending the session. Let us meet the next session. So please do subscribe for this channel. So Gate Conqueror, please do subscribe for the Gate Conqueror channel. So thank you so much. This two quadrant and four quadrant we will discuss later. We will discuss tomorrow.